Good evening, grade 11s. We're going to be looking at our new unit, exponential functions. So we're going to start with a review on powers, which you should be very comfortable with. So to define a power, we have a base, we have an exponent, and the entire thing would be called the power. The temptation is to multiply a times b, and that is not what it's defined as. A power is defined as a times itself b times. So the rules that we know: product, if you are multiplying two powers and you have to have the same base for these rules, and we multiply two powers that have the same base, for instance 3 to the power of 3 times 3 to the power of 4, that means 3 times 3 times 3 times 4 3s. 3 times 3 times 3 times 3. That we can write as a power as 3 to the 7. So from last year, from further examples, you know that algebraically, if you have two powers with the same base and you multiply them, you can add the exponents. Similarly, if you have two powers with the same base and you divide, so the first one would be 2 times itself 7 times, divided by 2 times itself 3 times. You know you can cross out common factors, so we would be left with 2 to the 4th. When we have two powers with the same base, you can subtract the exponents when you divide. Power of a power. For example, if you have 2 to the 3 squared, that means 2 to the 3, or 2 cubed, times itself twice, which we know the rule for multiplication would be adding exponents, would be 2 to the 6. If you have a power of a power, you can multiply the exponents. If these A's and M's and N's aren't really doing it for you, you could write a definition in English. Add exponents, subtract exponents, etc. Whatever floats your boat. 3 more rules today. Power of a product. If we have two things being multiplied together, 3 times x for instance, and we raise it to the exponent 4, that means 3x times 3x times 3x times 3x 4 times. That means there's going to be 4 3's and 4 x's. So that exponent affects both things in the bracket directly in front of it. If you have anything being multiplied raised to an exponent, that exponent will affect each bit. Likewise with a division, if you have two things being divided, 7 over 3 squared for instance, that would mean 7 over 3 times 7 over 3, which would be 49 over 9, or 7 squared over 3 squared. That exponent will affect the top and the bottom of that division. So if we have a over b raised to the power of m, it will be a to the m, e to the m, and a zero exponent. If you have any number you can think of, to the power of 0, it is always 1. A to the 0 is 1. So those are the rules we're going to use today. You can tell there's more coming. Let's do a few questions together. Express as a power of 4. So the number 4 itself is the same as 4 to the 1. 16 is the same as 4 squared, so we could write that using the rules of multiplication as 4 cubed. 4 to the 5th divided by 4 squared, using our rules for division, we keep the base, subtract the exponents, it's 4 cubed. And 4 squared all to the power of 7, you would multiply the exponents, 4 to the power of 14. 3x squared is the same as 3x times 3x, or 3 squared x squared, because that exponent affects everything in the bracket directly in front of it. Simplified would be 9x squared. Going in the other direction, 8 to the 4th times x to the 4th would be the same as 8x all to the power of 4. For C, x to the n times x to the m, squished up indicates multiplication, and we have the same base, so we can add our exponents. X to the 4 all to the n, we could multiply our exponents and write it as x to the 4n. X to the 4th times x to the n. This one is not the same as the last one. The base is the same, but we have multiplication, and with multiplication you add the exponents. Seven million 865,473 to the 0 is 1. 8 to the 15th times 8 to the 13th times a over 8 to the 10th times 8 to the 11th. So my numerator I consider one thing, and I am going to use the rule of multiplication and add all the exponents. So I have a to the 15th times a to the 13th times a to the invisible 1, so that I make sure I add that 1 when I add my exponents. That would give me a to the 29. On the bottom, keep the base, add the exponents, 21. My rule for division, when I have the same base, is keep the base, subtract the exponents, a to the 8. B is 3x squared y to the 4th all cubed. That cube is going to affect the 3 and the x's and the y's. 3 cubed is 27. X squared cubed, I would multiply my exponents and get x to the 6th. Y to the 4th cubed, multiply the exponents, y to the 12th. I am done. C is a little bit tricky because we have different bases, and that's a no-no. We don't have rules for different bases. So I am going to rewrite the 9 and the 27 as powers of 3 so that I can use my rules of exponents. 9 is the same as 3 squared. So I'm going to replace my 9 with 3 squared to the power of n minus 1. 27 is the same as 3 cubed. So I'll replace my 27 with 3 cubed. And now I have some tidy up. Before I use my rules of powers, I'm just going to tidy up those two powers that I replaced. 3 to the n times 3 to the 4n times 3 squared to the n minus 1. My rule for that would be to multiply the exponents. It's power of a power. So it's 3 to the 2n minus 2. There. And on the bottom, I have 3 cubed to the 2n plus 2. You would multiply the exponents with power of a power. So we would have 3 to the 6n plus 6. Now I can do some tidying. On the top, I have multiplication. My rule would be to keep the base and add the exponents. So I have n plus 4n plus 2n minus 2 as my new exponent. And on the bottom, I have 3 to the 6n plus 6. You don't have to write so many lines, but we want to be clear. All right. On the top, I have 3 to the 1n plus 4n plus 2n is 7n. Take away 2. Divided by 3 to the 6n plus 6. I have a division with the same base. My rule is to keep the base and subtract the exponents. 7n subtract 2, subtract 6n plus 6 will be my new exponent. 7n take away 6n is n, negative 2 take away 6 is negative 8. There is my final answer. Can I leave that? Yep, you can see it. There we go. X y squared to the power of 4 times 2zy cubed times negative xy to the power of 6. What a mess. Let's tidy up the top by doing the brackets to the exponent and using my rules of powers. Xy squared to the 4, that 4 is going to affect both the x and the y's. So I'm going to have x to the 4th, y to the 8th times 2zy cubed. That cube will affect the 2 and the z and the y. So I will have 2 cubed, z cubed, y cubed times negative xy to the 6th. Everything gets affected by the 6. And a negative times 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 a negative will be a positive. So I can ignore that negative. It is going to be positive x to the 6th, y to the 6th. All over x squared, y squared, z squared. Cubed. Cubed. Sorry. Going to tidy up the top for a second. I have x's, I have y's, and I have z's. And so I can use the rules of powers on things that have the same base. So I've got a number 8. I have x to the 4th, x to the 6th, and since it's multiplication, I can add those exponents, x to the 10. I've got 3 piles of y's, and when I multiply, I can add exponents. So I've got 8 and 3 and 6, 17. And I only have 1 pile of z, so I have z cubed over x squared, y squared, z cubed. Last but not least, I have division. So I've got numbers, x's, y's, and z's, and I can apply my rules of exponents. I have the number 8. X to the 10 divided by x squared is x to the power of 8. Y to the power of 17 divided by y squared is y to the 15th. And lastly, my z cubed divided by z cubed is a 1. I don't even have to write it down. Final answer, 8x to the 8th, y to the 15th. You've got lots and lots to practice, and we'll do a few tomorrow.